Good day, grade 8 students. For today, we're going to learn more about polygons. So for our previous lesson about relation among lines and angles, we learned more about supplementary angles, complementary angles, linear pairs, and vertical angles. But for today, guys, we're going to learn more about polygons. So a polygon simply comes from two Greek words, polus, meaning many, and gonia, meaning angle or corner. So that means when you combine those two terms, poly and gon, so that means many angles or many corners. So you see here, guys, we have here examples of different polygons. Okay, so what do you think, guys, are the polygon or polygons here on the figure? So I'm gonna give you guys 3 seconds. Okay, 1, 2, 3. Okay, so the answer here, there's only one polygon here. It's actually only this one at the center. The two polygons here, actually they're not polygons. The two figures here are not considered polygons, okay? So the first one is not considered a polygon because it's not a closed figure. Okay, so the definition of a polygon is first, it must be a closed figure, and the second one is also not a polygon, okay, because it has a curved edge or a curved side. Okay, so that's not also a polygon. So a polygon is any figure that has straight edges, okay, and it must be a closed figure in order for it to be considered as a polygon. So this one, what we have here is a polygon, so it has 10 sides, and that is a decagon. Okay, so this one, this figure right here is a polygon. And polygons can be seen everywhere. Okay, so you can see polygons in different places. Okay, so for example, you have here the Pentagon. So the Pentagon is a building in the United States. So it's the center of Department of Defense in the United States, and it's shaped like a, okay, from the word Pentagon, it's shaped like a pentagon. Okay, so there. So it's a five-sided building. It's a building that has 5 sides, and it's the center for Department of Defense for the United States of America. Okay, and they shape it like that for a very specific purpose. You can read more about it on different articles on how they shape the Pentagon that way. Then we also have hexagons, and hexagons like this one can be used in making honeycombs. Okay, so honeycombs are found, of course, in different beehives, okay, in different beehives or in different bee farms. And we have here honeybees, and of course they are the ones who create the honeycombs. And if you notice, the pattern that they create, the continuous pattern that they create are hexagons. Okay, so they're kind of like 6-sided polygons. Okay, and if you look closely at nature, you know, you can see a lot of hexagons that are used, because first of all, what you notice about a hexagon is it's kind of like a polygon that is very compact. Okay, it has closed spaces. Okay, so there. So this type of shape or figure is very well suited for nature because it's very economic. Okay, so the shapes there, the shape of the hexagon is very economic, and therefore when the honeybees create their combs, they can supply as many honeys as they can while saving up space. Okay, so the main reason for here is saving up space for the honeybees. And we also have buildings, more buildings that are shaped like different polygons. So for this one, we have here, actually it's shaped like a tetrahedron. Okay, so a tetrahedron is a building, or I'm sorry, a figure, a solid figure with 4 faces. Okay, so what we have here is a figure and a building with 4 faces. Actually, there are 2 buildings, but I'm sorry, they are collectively called as the Louvre. Okay, so the Louvre can be found in Paris. Okay, and it's kind of like a museum. Okay, so it's an art museum that contains like very expensive paintings and different sculptures. So the Mona Lisa, the famous painting of Leonardo da Vinci, can also be found there in the Louvre. Okay, there. So the Louvre is shaped like a tetrahedron, and it's an art museum found in France, and it's like a very renowned place, and it's shaped like a polygon. Okay, so the polygon there is a triangle. Triangles are also considered as polygons. And we also have here a building. Okay, so this building is a modern space building. So it has these sides, okay, these sides and these angles. Okay, so they have like a pentagon shape for the casing of the outside of the building. Okay, so moving forward, we go to this one. So the parts of a polygon, there are different parts of a polygon. The first one is the vertex. The vertex, or the endpoint, is the point where the two sides intersect. Okay, so for example, we have here a pentagon. So the vertex here is the point where these two sides meet, side AB and then side AC. Okay, so we've already discussed that in our first module and also our second module. And we also have a diagonal. A diagonal is a segment that connects two non-consecutive vertices in a polygon. So two non-consecutive vertices, that means that they are not connected. Okay, so for example, point B and point C are not connected in a pentagon. But if you draw a diagonal, that connects them, they become connected, and therefore it becomes a segment that connects the 2 points together. We have point B and then point C. And then a side is one of the line segments that is part of the polygon. Okay, so we have here different sides. Okay, so we have here side BD, side DE, side EC, side CA, and then side AB or BA. Okay, so you can interchange those two. Okay, so we have 5 different sides for this polygon, for this pentagon. Then an exterior angle. An exterior angle is an angle formed by 2 adjacent sides outside of the polygon. So the exterior angle there is here. Okay, so this is the exterior angle. So it's an angle found at the exterior, of course, of the polygon that we're describing. And this one is the exterior angle. So we can also derive other exterior angles. So this one is an exterior angle. This one is also an exterior angle. And also this one. And also this one. Okay, and then we have interior angles. So an interior angle is an angle formed by 2 adjacent sides inside of the polygon. So meaning of 2 adjacent sides, that means we have here, for example, segment BD and also segment DE. So they are adjacent sides, and they are connected by an interior angle, or an interior angle can be found between those 2 sides. And also this one, side DE and side EC. There's also an interior angle here. Okay, so we move on to the different types of polygons. So the first one is the convex polygon. From the word convex, so that means that the sides are extending outward. So it is the most commonly known type of polygon. And it's a polygon that has no diagonal with points outside of the polygon. So what does that mean? So for example, you have your point, and I draw here like a diagonal. I cannot draw a diagonal because the point is not part of the polygon, and therefore no diagonals can be formed outside of the polygon in a convex polygon. Then all of its interior angles are less than 180 degrees. So to compute for the sum of the angles of a given polynomial, you use the formula n minus 2 times 180 degrees. Okay, so what we have here is a pentagon, guys, for the polygon here. So we have here a pentagon. So we can use this formula. Okay, we can use this formula to find the measurements of the angles in the total angle measurement of the polygon that we have here, which is a pentagon. So we substitute n, which is 5. Okay, 5 minus 2 times 180. So what's 5 minus 2? That's simply 3. Okay, so 3 times 180. Okay, so what's 3 times 180? Okay, so that's simply 540 degrees. Okay, but it's written here that all of its interior angles is less than 180 degrees. So given that the total angle measurement of this polygon is 540 degrees and it has 5 sides, what we can do is we can divide that by 5, okay, to get the measurement of each of its interior angles. So the measurement of each of its interior angles is 108 degrees, okay, and that is less than 180 degrees. Okay, and the lines or segments found in the sides of the polygon do not contain points in the polygon's interior. So what does that mean? which means that the sides here of the pentagon, let's say this side AB, so this side here does not contain any point inside or in the interior of this polygon right here, the pentagon. Okay, then we also have the concave polygon. So it is a polygon with at least one diagonal with points outside of the polygon, and there's also one angle greater than 180 one interior angle greater than 180 degrees. So for here, we have a star figure, or a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, a 10 figure polygon, and we can also call that a decagon. So a star can be a decagon. And what we have here, it has at least one diagonal with points outside. So what does that mean? So if I draw, if there are 2 points here and I draw a diagonal here, it's possible because there are 2 points here that connect, that are part of the polygon itself, the decagon. And if I connect that, then we have there a diagonal. And also, there's also one interior angle greater than 180 degrees. So for this decagon, okay, for this concave polygon, so this is one of those angles, okay? So that's one interior angle right there, okay, that can be greater than 180 degrees, okay? So moving forward, we have a simple polygon. A simple polygon is a type of polygon where its boundaries do not cross itself. Therefore, all convex polygons are simple. So that means that the boundaries of a simple polygon do not cross itself. So that means for this octagon figure right here, for this 8-sided figure right here, it does not have boundaries, or it does not have sides that cross itself. Okay? But for a complex polygon, this type of polygon intersects itself. So this complex polygon right here can intersect its sides here, or at this part, or at this part, or any type of parts of the given complex polygon. Okay, and we also have equiangular polygons, from the word equiangular, so that means all of their angles are the same. And from the word equilateral, for the 6th type of polygon, the equilateral polygon is where all sides are equal. So the most common type of given polygon for that is a triangle. Okay, so there can be like 3 sides that are equal, and therefore the free angles that they have are also equal. Corresponding parts of congruent triangles are congruent. So let's say, for example, you have 2 triangles right there. Okay, so there. Okay, so those are the equilateral and equiangular polygons, and all equiangular polygons are also equilateral polygons. Then we also have the cyclic polygon. A cyclic polygon is a type of polygon where the vertices or points lie on a circle, called the circumcircle. So a cyclic polygon can be this type of polygon. Okay, so where all of the vertices of the polygon lie on one circle. Okay, so if I draw a figure right here, let's use a different color, red. So let's say, for example, I draw a triangle. Okay, so if I draw a triangle right here, okay, then if I draw a circle right there, okay, so all of the vertices of the triangle lie at some point of the circle. Okay, then we have an isogonal polygon. It is a polygon that is cyclic and equiangular. And we also have a tangential polygon. It is a polygon where all sides are tangent to an inscribed circle. So this is an example of a tangential polygon. Okay, so it's a polygon shape, a figure right here, a trapezoid, and all of the points here, all of the side of this polygon of the trapezoid is tangential, or is tangent to this circle that we have here. So for example, we have your trapezoid A. All of its sides, all of the sides of the trapezoid is tangent to this circle right here. Let's say that the circle is called circle B. Okay, then we have an isotoxal polygon. An isotoxal polygon is a polygon that is equilateral and tangential. Okay, so we have here an equilateral. Let's say, for example, this is an equilateral triangle. Okay, so for example, this is an equilateral triangle. It has 60 degrees. Okay, also an equiangular. Okay, an equilateral triangle is also equiangular, and it has what do you call this? It has points that are tangent to the circle right here. So we can call that as an isotoxal polygon, equilateral and tangential. And we also have a regular polygon, a polygon that is both equilateral and also an equiangular polygon. So the most common types can be found in the different Platonic solids that we have. So we have the tetrahedron, the hexahedron, the octahedron, the dodecahedron, and also the icosahedron. So all of its faces, all of the faces of those Platonic solids, so those are regular polygons if you measure them. So that means they have the same measurements for all of their sides. And we also have a skew polygon. It is a type of polygon that does not lie on a flat plane, but zigzags in 3 or more or higher dimensions. So this is a very weird type of polygon because it's composed of more dimensions. Okay, so we also have the rectilinear polygon. It's a type of polygon where all of the sides meet at right angles. So an example of a rectilinear polygon can be a rectangle. Okay, so all of its sides meet at right angles. Okay, so there's a right angle, a right angle, a right angle, and also a right angle.